Hi guys, Josh Smith here from Smith Boys Racing. We're stepping up the production now, so we've got Josh Smith presents Fun with Sidecars. This is what we build, so we're getting pretty high tech with the YouTube. So you know So just a quick video tonight. Just was playing in the garage today, waiting for some paint to dry. So I decided to knock up some handlebars. I want to make similar to the style I run on the senior bike, which is a Pro Taper style. I've had a look on eBay. They're aluminium. So I didn't want to use the aluminium one. I wanted a one piece handlebars. I can't weld aluminium to chromoly, aluminium to stainless. So just playing around today. Just with some bends, on the tube bender. So I thought I'd just do a video on just some basics, sort of tube bending 101. Some problems I faced today. First thing when you're bending tube, you need to know your die selection. You need to know your wall thickness you're going to be working with. That will determine the centerline radius, the minimal diameter, the minimal wall thickness that you'll be running on the tubing you want to be working with. So the manufacturer will tell you each of those. So Speedworks, for example, you'll buy a die, they'll tell you, 65 thou, which is 1.5 millimeters metric. So they'll tell you a minimum CLR for a wall thickness. What they don't tell you is that is mild steel, or the equivalent of a mild steel. So it might be a chromoly or something. If you start getting into bending stainless, which I was doing today, 316 stainless tube, that changes dramatically. You'll find a lot of issues with it. Sometimes, which I found today, and I'll get into that. So the first thing you have to realise with tube, when you're bending tube, imperial. You can get metric, but the majority of them are US based, so they will be talking in imperial. So you need to get your head around imperial. Next, tube. Tube is measured outside diameter. People confuse it a lot with pipe. Pipe is nominal bore, they'll be talking ID. So you need to know the difference. If you buy yourself a pipe bender, you won't be able to do much. So they're two different things. Pipe is fluid transport, or gas or something, so they'll be talking nominal bore, whereas tube is outside diameter. So once you get your head around that, and your head around the imperial, it's pretty simple from there. Knowing your centre lines. So one rule of thumb that I've heard, and it's pretty true for chromoly and mild steel tube bending, is the diameter that you're going to be working with times 3. That works pretty well for chromoly. So say a 1 inch tube you want to do, you could have a minimum 3 inch CLR for your die. So it's a 3 inch centerline radius. That would work out well, and it would give you good bends. I tried it on stainless steel, 65 thou, kink tube. So a 3 inch does not work with 316 stainless. So I had to get a 4 inch. I needed to get one anyway for another bend that I was doing. So I would say stainless steel if you're doing a lot of stainless steel. 316 tubing with 304 tubing. I would go with the 1/4 times the centre. The tube diameter to give you the minimum. So 1 times 4 for stainless works out pretty well, not 1 times 3. So that works pretty well. So I've been playing with the 7/8 die, 3 inch centerline radius. I made up some swinging rails. I made up quite a few, just out of off-cut bits of stainless that I've come across. So I've made this one, bends up really nicely, no kinking, very nice. These are only 600mm lengths, just good for doing little, especially how I made my cheetah. I'll talk about this one in a minute too. The cheetah, really nice bend, no kinking. So today, I started out, just meant the way that my process, everyone's got their own process, this is how I work. I just bent up this bit of a 2.4mm TIG wire, aluminium TIG wire. Just marked out some centres off a set of Pro Taper bars that I've got. This half being Pro Taper and this half being the twisty, kinky sort of side that kicks down for when you're hanging off the bike. So I wanted to work on this one, but what I was trying to work on, the minimum distance between centres when you're bending back to back. I'd never done that before on this one. So I need to determine that. So I had a play, I ended up working out that I could get to 50mm between the two bends when you bend back to back. So this is what I ended up with. But I cut it because it was too far for the handlebar that I liked. So I ended up cutting another, I think it was 25mm out of it, put a bit of 3/4 stainless inside it, and then I will do an open square butt weld, and I will weld this piece inside, weld the whole piece when I index it the way I like it. So I think I'll put a 15-degree kick on it. So that's what I was sort of playing with today. This one went really well. I had quite a few lengths of 600mm stainless, just offcuts. This one went really nicely. This one went really nicely. Was the one piece, then I cut the 24mm out of it, just to index it a bit where I want it. Also to shorten that back-to-back distance. Then I decided to try and work on the right side, this being the left. I decided to try and work on the right. This was a 50-degree bend, this one also. I wanted to do a 30-degree bend. And picked up another bit of stainless and kinked. Kinked again. Kinked. I was like, okay. I've never had issues with this before. I've made up quite a few swinging rails. Made the cheetah, made other bits and pieces. I did nothing different between this one and this one. Did all my same process, but kinked it. Which I wasn't too worried about. I know I've had this issue before. This is 1 1/4. This was just a test bend I was doing. This was 1 1/4 on a 4-inch CLR on 316, and I kinked it. So this was just a test anyway. No big deal. They were just tests as well, so it wasn't an issue. So then I thought, okay, I'll try another piece. Got another piece out. Went nicely till I get to about, I'd say probably 15 degrees. Kinked. Kink. I'm not going to use it. It's just not the way I work. I like things to be perfect. 2 kinks, but I'm not going to use it. So I thought, okay, must just be a length of steel that I got. Try another one, cleaned up another one. I thought, surely they didn't all come from the same length of steel. Next one, same thing, kink. I know what the issue is. It's the wall thickness on the centre line radius. It's too tight for the 316 stainless. Having said that, it's no issue for the chromoly, so I might just have to make them out of chromoly. Either try a different length of steel because it doesn't have the ductility that I sort of need to deform the 316 the way I like it. Although it does on some lengths, so that's sort of where I'm at with them. I sort of put them to the side now, but I thought it'd just be good to share that. Just the rules. The back to back, there is a minimum. You do need to know that. You'd have to play around with that on each bender. They would vary. So on the cheetah, what I've done here, I've engraved this one. This is the 3-inch CLR on the 78316. You need to know the distance to the start of your bend. You need to know how much minimum you have to hold the tubing, to clamp the tubing. I've done the scale on it, degrees, marked off the back guide, and done millimetre increments that I marked out first. What you also need to know is how far behind your guide block or your follower you will need after you do a bend. That you also need to know, just in case you do like have another bend, bending back to back or something, through your follower rather than through your clamp. So, as I said, this is a Speedworks one. I forgot to mention it last time, but one good thing about Speedworks, they do zip pay, so no upfront costs, free delivery over $250 order, so that's quite handy. No upfront cost. I actually got this on zip pay. I just paid like $50 a week or something over a few months. I'll put a mark just on the side here. I always put a mark, so when I scribe my piece of material, I'll put it in. I can index that mark, so if I ever have to put it back in, I have a reference to go off on the side. I usually have a scribed line, and that just helps me index it as well. I've spoken about these before. I use these little pieces. As you can see, this was the start of my bend. So I've no dimples, no scratches or anything on it, especially stainless. There's nothing to hide behind. So when you put it in, you'll load it up and you'll take all the imprints will go into that piece rather than into your work piece that you want a nice finish on. So that goes in when I load it up. This one here, you'll see I'll mark a line all the way around the tube as well. That's a rough one. When I load it up, that's my reference point. I'll also usually have the line on the side I'll line up. If I'm not happy with the bend and have to reload it, that line always marks, that line marks line up with the start of my die, and I always know that's where it goes. So that's another one. When I finish a bend, that's the same. So you can load it up any orientation before you do the bend. That's why I like that mark around it. I'll put an SB on the side for the start of the bend and an arrow to say which side's going to use the material. So the bend side, I'll also write the angle down, just so I have a little reference to go on when I'm actually at the bender. Once I actually do the bend, once it's loaded up and I've bent the tubing to where I like, they are a very precision machine, little benders. They are. So that's where my bend was. That's a line that starts, always lines up. So once it's all fit up, and I've done the bend, what I like to do, I'll get a pen mark. I'll mark on the back of the guide block. What that does, it allows me to, when I pull it apart, it gives me a line. So I have another bend. I can measure off the back of this bend to my next bend, to the start of my next bend, which I'll put SB and the material that side. So I always use that at the end of my bend. I always like to mark that guide block. It's another habit I've gotten into. It's just part of my process, everyone's different. A couple more pointers with this. This is the guide follower. The manufacturer recommends this is to be greased. So as you do some bends, chuck some grease on it. I've just got a tub of Valvoline in there, and I just a finger on it. It's good for probably 3 or 4 bends before you put another little smear on it. You don't need to go overboard. Few maintenance tips with these. Actually, another really good tip. These are the material that these dies are made of is the same material as the inner race of a bearing. So it's a very hard material. It will last you thousands of bends, many years if you look after it right. One thing I like to do, make sure you do before you do a bend, deburr your material, the outside material. There's stupid amounts of pressure on this as it's forming. It's actually deforming the tube to get that shape. Huge amount of pressure on this and also the guide follower. So you don't want to be scratching through any burrs or anything. What it'll do, if you do somehow get some marks in it, if you are doing stainless for a client or something, you will end up getting a big groove in it. Possibly, well, highly likely that you will get a groove off if you groove up that just with the pressure that it is exerted upon. Another thing I like to do when I'm storing them, pull them out, inox them all up. CRC, similar, bit of oil or something if you do an oil change, oil them up if you're not going to use them for a while. Wrap them up in a rag or cling wrap or something, store them in a box. They do rust up if you don't. When you do use them, if you do inox them, they cannot slide. They cannot slide on the die. It is a pressure die. You need to fully wipe it down. It cannot have any inox or oil or anything on it. It needs to be, the tube needs to stick in there and stay in there and pull around with the pressure. The only one you'd oil up, if any, well, it is recommended to do the guide follower. But yeah, when I'm storing them, if you want them to last a long time, oil them all up, store them. That's one more thing. I'll just touch on this one. Your degree pointer, Speedworks degree wheel. It's still a 180. It is a fixed one, not like the JD squared one, so you can't actually index. So you end up putting TIG wire on it, but you keep having to, when you zero your workpiece, you keep having to move your TIG wire to get your zero, which is a little bit annoying rather than moving your degree wheel. I might put a JD squared one on this yet. I always have a habit, because you're bending over this side, you're sort of bending in this position, you get a bit of parallax. Just with your sight, you're not looking parallel, you're bending it, you're trying to hold a bit of spring back. You have to look straight at the index. So you sort of look at it from this angle, and I have a habit of overbending. So what I start doing now, I know that I sort of overbend a little bit just from how many times I've measured and pulled bends out. Now I set this index pointer on like 1 degree. So I actually don't go to 0, I go to 1 degree now. So that if I do go over a little bit, if I want 35 and I go 36 here, it is really only 35. So that's one little trick as well. You don't need to go to 0. You can put it a little bit earlier. Already call it 1 degree, and it'll give you a little bit of allowance if you do overbend. That's another tip. Spring back. People talk about that a lot. What spring back is actually the tube. When you're bending the tube. So when you're bending tube, it was a straight piece. It was either the way it was manufactured was either cold rolled or cold drawn or some other process involved. So it's laying out as a bit of tube. When you're actually bending, the processes are deformation. So springback is actually the material trying to return back to its original position. Usually is about 5 degrees or something. So that's what the springback is. Springback can work in your favour when when you do an overbend, you can just put it in the vise. I put it in the vise, some soft jaws on it, and you can actually, the deformation and the spring back, the memory that the tube does have, it can work in your favour. You can pull it back out, 1 or 2, 3 degrees, no worries. So once you sort of know the basics behind it, you can sort of adapt different processes, different tips and tricks, and just find your own sort of process that works for you. Take quite a few people's tips and tricks, make your own little process that you find works really well for you, and gets the best results for whatever you're doing. So that's right, we'll call it a wrap at that, and we'll catch us next time, guys.